It's getting noisy. Everyone's getting a voice. You know, I'll probably screw this up, but it's, I think Andy Warhol said in the future, everybody will have 15 minutes of fame. I think we need to change that. I think in the future, everybody will have 15 minutes of privacy. You know, you know, there are so many outlets now that everybody thinks they're famous, and maybe everybody wants to be famous. But we have an enormous amount of channels to talk about ourselves, but really talk about things that are important, to share things that are important. Let's think of some of the data points here. Last year, on Twitter, people sent out 25 billion tweets. I don't think anybody read any of them, but you know, so I'm just kidding. I actually think tweeting and Twitter is very, very interesting and worth understanding more. But you know, people are posting on all sorts of platforms, lots of valuable information. It's changing the nature of journalism, right? You have the emergence of citizen journalism. You know, I probably get an increasing amount of my news knowledge from social media and other channels rather than mainstream newspapers and television. They still constitute a good deal of my consumption, I imagine many of yours, but you're probably now consuming information that hasn't gone through the sort of traditional paths of news. And so it's going to get very noisy. The question is, how do you filter that, right, from the perspective of, if everybody has an opinion and sort of every channel that is determined and every organization is determined, we're going to have a point of view, how do we filter that and make that something that is meaningful? You know, after all, if there are thousands and thousands of voices, it just becomes a blur. It's not that useful. And that's something we're going to have to figure out as time goes by. One of the growing areas of technology that really, I think, touches what is at the heart of what you are about in your professions, your world, is the amount of information that is now being stored and what that means. And I want to take a few moments to think about this, okay? One of the data points that struck me just a few years ago was Eric Schmidt, who at the time was the head of Google, now is the chairperson, but at the time was running it. He said that from a data source, every 2 days today, every 2 days, we're creating more data than all the information ever created from the start of time to 2003, right? So whatever you think that time period is, the amount of humanity's collective information stored from 0 to 2003, whatever period, we're creating every 2 days. Every 2 days. So it's quite a large volume. And by the way, it's exponential. It's not like, you know, creeping up gradually. So we're entering the period of big data, lots and lots of data. And that has very significant and important consequences. So what's the zettabyte? So I'll get a little bit nerdy here, but I like this. I think this is really neat. So a single item of digital information is called a bit, right? And if you get 8 bits, you get a byte, right? And a byte is like a character. It's like A or B or C, right? So we have 8 characters is a byte. 1,000 characters, 1,000 bytes is a kilobyte, right? 1,000 kilobytes is a megabyte. And 1,000 megabytes is a gigabyte, you know? 1,000 gigabytes is a terabyte. 1,000 terabytes is a petabyte. 1,000 petabytes is an exabyte. And 1,000 exabytes is a zettabyte, right? It's a 1 with 21 zeros. Anybody know what comes next?
I was going to ask that. It's already at Z. So
it's a yottabyte. 1,000 zettabytes is a yottabyte. And so it would have seemed just a few years ago, these kind of numbers and this kind of data storage just seemed the work of science fiction or something. And now we're hitting and getting close to creating zettabytes of information. You know, you look at something like the Hadron Collider, which is that sort of circular big machine in Geneva, Switzerland. It's trying to figure out, some scientists are trying to use it to figure out the origin of the universe. And you know, they're running it now, it's active. And it creates so much information every single second, we have no way to store it. It's creating terabytes of information every single second, right? We don't have any computing power to store it. So what we have to do is sample it. We have to just take a slice of it. And that's the kind of world we're living. You know, as we collect information at this scale, it's going to tell us unique things about our humanity and who we are. Perhaps stuff we don't want to know, but in many ways, really important stuff that can help us make decisions as individuals and as a society. So here's an example. I think you might enjoy this. Let's take a look. Let's think about Google for a second and the flu, right? The impact, the occurrence of flu during a flu season. So when people have symptoms of the flu, they may do a Google search. They might search for things like medication, or they might say, I have the following symptoms, what do I have, right? And so you would say that as a consequence of the frequency at which people are inputting those questions, it might indicate perhaps the range or the scope of flu. So let's keep that thought and put it aside for 1 second. Before Google, it was still important to know where was flu happening in the country, you know, so you can distribute medication, you can respond to it, and the first responders can be prepared. And also, at a national level, do we have an epidemic? Do we have a problem? This was really done by the Center for Disease Control in Georgia. And they used really complex predictive modeling, and it was quite good, but it was hard, and it was very often sort of historical, sort of time had to pass before you could make some you get enough information to make some good, solid predictions. It's good, but sort of flawed at some level, right? Well, with Google, people are making the searches real time, and all the searches are being stored, by the way. It's not secret what you're searching for. Google stores that. And it's real time. So as people are searching, you know, the incidence of the mention of flu and associated is available in a database to be analyzed. Well, what you're looking at here is the orange line indicates the actual data for flu outbreak, and the blue is the trend that was extrapolated from the searches that were done on Google relative to flu between the period of 2004 and 2010. It almost matches it identically, right? That's pretty remarkable. So we don't have to wait for historical information. You can look right now and determine, you know, what's the frequency of flu in the United States by zip code, probably right down to a street level, I guess at some level, or at least a neighborhood. And you can do that real time. No need to wait for the information. That's because we're storing this enormous amount of information and we're able to analyze it. That's just one example. I like that one because it's so immediately practical and it resonates with so many people. But just think about the amount of things we could predict and could be able to understand on a real-time basis as we collect enormous amounts of information. This area of big data will profoundly change how we do stuff, how we make decisions, as individuals, as organizations, businesses, and as governments.